Time for a crash course in the rules of exponents. Let's use this guy. You like this guy? Okay. So we have x squared times x cubed. What does it equal? X to the 5, x to the 6, or none of the above? X squared times x cubed. Well, let's find out. What does x squared mean if you make it into like a factor tree? X times x. What does x cubed mean?
X times x.
X times x times x. How many x's?
5.
So the answer is x to the 5. So the rule is, when the bases match, you do what with the exponent? Add when you're multiplying. Okay? Now, one rule. Next rule. X to the 6th over x to the 4th. Well, what does x to the 6th mean if you write it out the long way? Right? That's why we invented exponents, to indicate repeated multiplication. On the bottom, what do we have? Okay, and here we have a battle between top and bottom. All right? We're in a fractional war here between the numerator and the denominator, because things can cancel or eliminate at this point. If you don't know what I'm talking about, what's 4 over 4? 1. What's 8 over 8? 1. What's x over x? 1, as long as x isn't 0. I have to add that. X over x isn't 1 if x is 0, because then it would be 0 over 0, which is not defined. Whatever. Okay, so x over x typically they cancel when one's on the top and one's on the bottom, right? And when they cancel, they technically become little ones. We don't always show them, but they're there. 8 over 8 is really 1 over 1, which is 1. And 4 over 4 is 1 over 1, which is, and x over x is 1 over 1, which is 1. I want you to keep that in mind, because as we're eliminating things, okay, as we're eliminating these x's, they don't become zeros, they become 1s. All right? This x over x becomes 1 over 1. This x over x becomes 1 over 1. This x over x becomes 1 over 1. And we're left with, and this is the long way of doing this, so you know why it works. Yeah, 1 times 1 times 1 times 1 times x is x squared. And on the bottom you just have 1, so I'm going to save ink. Laser, imaginary ink, but I'm saving it nonetheless. We don't have to write it, right? We don't have to put x squared over 1. It's just x squared. So the moral of the story is, what do you do with these when there's one on top and bottom and the same base is there? Subtract them. But what if it's bottom heavy? What if the x to the 4 was on top? You would end up with a negative exponent and you switch it. Or you say, here's how I think of it. Which has more x's, top or bottom? So it ends up there. The bottom has more x's, so that's where x is going to end up. By how many? 2. We can't really have over x squared. I didn't say anything, right? We can't have nothing over x squared. We need a placeholder up there. 1. Another way of doing that is to bypass that and say, let's still subtract. What's x to the 4 minus 6? X to the negative 2. And there's another rule of exponents that says if you have a base to a negative exponent, you flip it. All right? That becomes 1 over x squared. You see, a negative exponent says, hey, base, go down to the bottom and take your exponent with you. They talk. All right? So we had a lot of rules of exponents that you were supposed to learn in like 6th, 7th, and 8th grade, and we forgot a little bit, and that's okay. Because they're going to be pretty basic like this. Until you get to power to a power. Is this x to the 5, x to the 6, or x to the 8? Because 2 cubed is 8. Those are your options. It is x to the 6, and here's why. X squared cubed means x squared times x squared times x squared. Now that we're multiplying, right, because cubing means times itself 3 times. All right? Now that we're multiplying, what do you do with them? 2 plus 2 plus 2 is 6, so it's x to the 6th. Don't believe me? Well, this x squared is x times x, this x squared is x times x, and this x squared is x times x. So how many do we have? 6. So the moral of the story is when you have a power to a power, you do x to the a times b. You multiply. But wait, there's more. What if there's a number with a letter with a power to a power? Well, you see, variables and coefficients, coefficients, fancy name for number, right, up front, they follow different rules. Numbers are normal. This says to do 3 cubed, so don't put 9. 3 cubed is 3 times 3 times 3, 27. So the numbers follow the normal rules of math. It says to cube it, so I'm going to cube it and get 27. The x squared, however, is a variable with an exponent. So when you have an exponent to an exponent, what do you do with them? Multiply. 27x to the 6th. Here's how you could check your work. You could pick a number, accept 0 and 1, and plug it in for x. So someone said, can we use our calculator tomorrow? And I said, yes. So you could pick your favorite number, let's say it's 4. You could type parentheses, 3 times 4 squared cubed, you know how to use the little caret on your calculator, and see what you get. Then you could go in and you could type 27 times 4 to the 6th. We're just plugging in our favorite number. Don't use 0 or 1 because they're kind of special. All right? Plug in a number like 4 or 2 or 18. And if you get the same thing, you did it right. Did you get the same thing? Oh. Uh-oh. And here we are checking our work, and we think that. Okay, we're here. 3 times 4 squared cubed is, great, 110,592. Is that the same as 27 times 4 to the 6th? All right? So we plugged it in. Oh, you know it's even easier. Everybody, you know it's easier. Watch this. We wanted to plug 4 in for x. It's awesome, isn't it? That's called the... It's not even bright enough. He didn't tell me. We're storing 4 in for x. It's called the store button, and it is right above on. See it? Once you store your number in for x, you can just type this. Is that semi-visible? Okay. You can type parentheses 3x squared cubed. Is that the same as 27x to the 6th? All right, that's even easier than trying to put the 4 in. A nice little trick to check your work.